That is pyrrolidine group. The alkaloids which contain the pyrrolidine group and pyridine. Pyrrolidine means tetrahydropyrrole. Actually, this is the pyrrole. When you hydrogenate it, we will get the tetrahydropyrrole or hexahydropyrrole. Hexahydropyrrole is known as pyrrolidine. So one, that is pyrrolidine, pyridine. One is pyrrolidine group, another is pyridine. And we know pyridine is this one. Pyridine is heterocyclic. Pyrrolidine is also heterocyclic. The difference between these two is it is 6-membered, it is 5-membered. Second difference is pyridine is aromatic, while pyrrolidine is non-aromatic. That is saturated compound. So now here, this is the chemically we call this group as the pyrrolidine pyridine. That is the drug which contains the two groups, pyrrolidine and the pyridine. Nicotine is a brownish liquid compound. You know, mostly all the alkaloids, they are solid in nature, but only few alkaloids, they are liquid. So nicotine is one of them. That is the liquid. Its molecular formula is C10, H14 and N2. That is 2 nitrogens. Melting point is 247 degrees. So this is the main factors of the nicotine. Actually, nicotine is found in the tobacco leaves. In tobacco leaves they contain the nicotine. The dried leaves of now the plant which is botanical name Nicotina tabacum. Actually, we say this is nicotine. Sometimes it is also known as, we can call also this compound nicotine as anabasine. Anabasine. Actually, it is a chemical name of anabas. There are 3 isomers. One of those is anabasine. So now here, nicotine, actually it is not drug. When we have drug, then we'll use the SAR, structure activity relationship. But what will be the different effects on the drug? Whether alkaloid, mostly it is found naturally in plants, tobacco leaves. And we know the extraction of this compound, this is basic compound. So to extract the basic compound, what we do, we dissolve in dilute acids. When you dissolve in dilute acid, what happens? This compound will be soluble, becomes soluble and comes in the aqueous solution, leaving behind the insoluble organic materials like cellulose types. So once we have the 2 types of solution, 2 layers, one will be organic, another will be inorganic. Or we say aqueous layer. Aqueous layer will contain the nicotine dissolved in dilute HCl. So just remove the inorganic, organic substance and take out the aqueous solution. That aqueous solution will contain the dissolved, this salt of nicotine. The acid salt of nicotine will come in the aqueous solution. So now again, when we have nicotine as the solution, then what have to do? Just to add the, again, you say base, so potassium hydroxide. Again, potassium hydroxide will react with the base. And what happens? Again, the nicotine will be released. Once the nicotine, there are many steps, 3 or 4 steps, but these are 2 or 3 simple steps. That is just you treat with the dilute acid to convert the base into dissolved salt. Then it comes into aqueous solution. After extraction or isolation, the organic material is removed, and this dissolved salt, again it is converted into nicotine, and then by fractional distillation we can get. Otherwise, there are 2 more steps, but these are simple 2 steps by which we can extract the nicotine. Otherwise, if you say no, if you increase these steps, then first step will be the parts of tobacco, mostly the leaves. These after extraction with the acid, then water soluble salts of alkaloids, they are removed from in the aqueous solution and leaving behind the cellulose, chlorophyll and cellulose material. Secondly, extract is acid extract is then made basic with the lime, basic like we use the sodium hydroxide or potassium hydroxide, and steam distillation After distillation, what happens? It separates nicotine from the water-soluble non-volatile materials like sugars, inorganic salts, others. Third step will be to distillate the acidified, distillate water with the aqueous solution. It is acidified again with this solid oxalic acid and concentrated to a syrup. If you concentrate evaporate this liquid, there will be a thick solution will be obtained. On cooling, the crystalline salt of nicotine and oxalic acid will be separated. Other alkalides which are not forming slightly, which are not forming, they are slightly soluble, remain in the solution. We will get the now what happens is solid. We will have the liquid nicotine brownish, and then other salts they will remain in the oxalates. After that, the crystalline nicotine, which is brownish, nicotine oxalate, it is now nicotine oxalate salt, is then transferred to a separating funnel and treated with excess of aqueous potassium hydroxide. Then nicotine thus set free. When we have oxalate salt, nicotine oxalate, that is a soluble, crystalline substance. If you treat with the aqueous solution of potassium hydroxide, nicotine becomes free and it becomes it comes on the surface as a brown oil and separated by extraction with ether. The ethereal solution which contains the nicotine is dried over solid anhydrous potassium hydroxide and ether evaporated. For further purification, residue is fractionally, we will carry out fractional distillation. That is on vacuum, because vacuum, the distillation will take place at lower temperature. Its decomposition will be just saved. Now, we will have, as I told you, it is liquid. Most of the alkaloids, they are solid, crystalline, but it's liquid. Now, the next problem is to determine its elemental detection, elemental analysis, or its molecular formula. From simply from the simple molecular formula, then the molecular formula, the empirical formula, then molecular formula, molecular weight. It has been observed that it is molecular weight C10, H14, and N2. You know, one of the reaction we have done already, Harsdik-Meyer method. Do you remember this reaction, Harsdik-Meyer method, in which the compound when treated with methyl iodide, then if methyl iodide is treated with the compound, then methyl group is attached to, if you remember it, hydroiodic acid. If the compound is heated with the hydroiodic acid at 200 to 300 degrees centigrade, then what happens? If the methyl groups are attached to the nitrogen, they will react with the methyl iodide to form the hydroiodic acid to form the methyl iodide. So it has been observed from that 2 methyl iodide molecules are formed. And we know 2 nitrogens are there. This means the 2 nitrogens, both nitrogens, they contain the N-methyl group. The N-methyl groups are present, means 2 nitrogen groups are there, and both are containing the N-methyl group. This is confirmed by the Harsdik-Meyer method. Now then there will be the problem that how we say what is the side chain. Normally when this reaction, the nicotine is oxidized. When nicotine is oxidized, let me write here. When nicotine is oxidized, when nicotine is oxidized, then it is converted into nicotinic acid. When nicotine is the nicotine is say only C14 C10 H14 N2 nicotine when oxidized with chromic acid or potassium dichromate. Normally we use the potassium permanganate or potassium dichromate, any of one of these oxidizing agent. Then when it is oxidized, we will get a nicotinic acid. This compound is obtained. Nicotinic acid. It means the nicotine contain one of the part, the what you call pyridine, and pyridine is attached with the other portion at this position. We say it is 1, 2, 3, or alpha, beta. This is the gamma position. These are the 3 positions. 2, 3, 4. You know we have 3 isomeric pyridine carboxylic acids. Here we say 2 pyridine 2 carboxylic acid, pyridine 3 carboxylic acid, pyridine 4 carboxylic acid. Pyridine 1 carboxylic acid. Here you see 2 carboxylic acid is also known as pyridine alpha carboxylic acid. 3 pyridine 3 carboxylic acid is pyridine beta carboxylic acid. 4 pyridine 4 carboxylic acid. So these will be different names. If it is lying carboxylic acid lying at the 2 position, we call it picolinic acid. Picolinic acid. If it is lying at the 3 position or beta position, we say that nicotinic acid. If it is lying at the 4th position, we call it the isonicotinic acid. Isonicotinic acid. If you call methyl pyridine, then this will be the picoline. Normally, the common names of the methyl pyridines are picolines. Picoline may be alpha, it may be beta, it may be gamma, depending on the position of the methyl groups. But here too, one is known as picolinic acid at 2 position, nicotinic acid at 3 position. This will be the isonicotinic acid at the 4th position of the pyridine. So now from this, we say the pyridine, the nicotine contain one of the ring as the pyridine. Pyridine is present in the one of the part. Now further formulas is confirmed that it must be the side chain which contain the nitrogen. We know the 2 nitrogens are there. Both nitrogens are tertiary. Both nitrogens are tertiary in nature. Nitrogen are tertiary in nature. Now, second thing is that the side chain which contains the nitrogen. It is we call it it is saturated. How we can know from this that this is saturated? If the side chain is there, now what happens? You see, hydrogenate this. For example, if you for example, a simple reaction, benzene. If you hydrogenate benzene, how many hydrogens will be added? 6 hydrogen. 6 hydrogen atoms, 3 into 6 hydrogen atoms are 3 molecules of hydrogen. So we will get here benzene will be hydrogenated cyclohexane. Normally we call the how many hydrogens? 3. Hexahydrobenzene is obtained. If, for example, if you don't know the double bonds present in the benzene ring, but if you hydrogenate it, if 3 hydrogen atoms molecules are 6 hydrogen atoms are added, it means there are 3 double bonds. If total 6 hydrogen atoms are added, it means total number of double bonds present in the benzene ring is 3, because each double bond will consume 2 hydrogens to be converted into single bond. One double bond when converted into single bond, we need 2 hydrogen atoms or 1 hydrogen molecule. So here 6 hydrogen atoms are added, means there are 3 double bonds. When the nicotine was hydrogenated in this way, similarly when the nicotine was, say this nicotine is hydrogenated with this one, that is hydrogen in presence of nickel or platinum. Then it was absorbed, then again 6 hydrogens were added. 6 hydrogen means hexahydro compound is obtained. Hexahydro compound is obtained. If hexahydro compound is obtained means 6 hydrogens are atom. 6 hydrogens are atom, and we know one portion of the nicotine contain the here pyridine as the part, and pyridine either write in this way or we write just in this way. Here means 3 double bonds are there. So it means 6 hydrogens are added to the pyridine to be converted into hexahydropyridine, or which is also known as piperidine. Piperidine is the saturated form of pyridine. So maximum, if you hydrogenate, only 6 hydrogens are added, not more hydrogens are added. Even you use any forcing conditions, or if you increase the temperature, even then there will be no further addition of hydrogen take place. This infers that the only pyridine portion is aromatic, remaining portion is not aromatic, remaining portion is saturated. That is, already it is saturated, so there will be no hydrogenation. Means there is no double bond, there is no aromatic compound in the side chain. And we know side chain is attached at the 3 position. Now this is the one point. Another point is, when nicotine is treated with the, let me write here, when here, when the nicotine is, let me clear it. Here today we know the structure of, but initially when the structure of nicotine was not known, when it was first treated with the hydroiodic acid, then followed by the methyl iodide. Then the compound obtained was C10H14 and N. Here what will be the N? N2CH3I. N2CH3I iodide. This is not a methiodide or methiodide. Nicotine as isomethodiide. Nicotine.
Sir. Sir, he methods on stick. Sir, he methods के पान कहीं पे हियां जे के ता स्टार्ट कया तो ता चयो तो स्ट्रक्चर जी सर स्ट्रक्चर ता पेरे चयो तो अननोन पाके खबर न हुई तो ही जे के पान मेथड्स करी पे स्ट्रक्चर इलेक्ट्रिशियंस लाइन बना स्ट्रक्चर
जी बाबा जी हाथ काम था बाबा
सर ही जे के पान मेथड्स करी पे हियां जे के ता स्टार्ट कया
गला छा जी छा खबर आवाज छाचो
सर ही जे के मेथड्स पाण करियो पे स्ट्रक्चर फाइंड करन ला मेथड्स हैं ना ये सर
जी हां बिल्कुल सही तो
प्रीवियसली पाके खबर न हुई तो हियर मना के पाण लिखियो ते निकोटीन है वीडियो में
हां खबर न हुई सही तो बिल्कुल
पाण बोर्ड ते निकोटीन लिखियो पर प्रीवियसली ते पाण अननोन कंपाउंड हुयो माने अननोन करे पाण कयो तो पाके रिजल्ट्स उहे मिलियो जे के डायरेक्ट
हां सर हाँ सही तो बिल्कुल सही रिएक्शन
जी सर ये मेथड जे के पाण कयो पे स्ट्रक्चर इलेक्ट्रिशियन लाइन माने स्ट्रक्चर फाइंड करन ला बाकी की खबर पे स्ट्रक्चर छा है जो
स्ट्रक्चर इल्यूसिडेशन एग्जैक्टली स्ट्रक्चर इल्यूसिडेशन जनरल मेथड पाण करे आया थी एको डिटेल में करना थी सजो पाण भले चलन ला खबर उन डिटेल में करे थी जेके फ्यू रिएक्शन जेके सीधा रिएक्शन से 4-5 हुए तो कया otherwise we are not doing all reactions because all reaction detail we have done generally in the starting I used to tell you all the methods general methods used for the determination of structure of unknown alkali. We have done all methods. Those methods can be applied over here. Now we are going to apply those methods here, but not all methods, only few methods we are applying over here, because we know last time I told you there are 2 types of methods: physical methods or analytical methods and chemical methods. We are just only doing here chemical methods. Few methods, not all methods. Few, because we are online. If you do all reactions, this will require more time. Just few reactions we are going chida, just most important method we are doing over here. Again, you see, finally, if by the different chemical methods, whatever the structure is proposed, then proposed structure can be confirmed from the synthesis. So few important reactions, and then finally we'll do the synthesis. This is all about the every drug. But if the drug is used in taken as a medicine, then we use we will add the SAR, structure activity relationship. Just like in quinine, we'll do the morphine, but nicotine is not a drug. Actually, it is poisonous. People are using to smoke it in smaller quantities, but in higher quantities, it can be used as a pesticide. Actually, this was used for the killing of say it is actually it uses pesticide. But now people they are just and Nicot was the first scientist who in France he used to propose this drug for the smoking. That is why the name is nicotine. Otherwise, nicotine is not favorable for the human or any animal. Even in pesticide, when it is spread over the farms, then the animals are not allowed to eat it. If occasionally they eat, they can become ill. So now this is not drug. When we use the drug that is used as a medicine, then we use the SAR. That is structure activity relationship. Because some drugs for those it is available data, that is SAR. Whatever the structure we change, what will be the effect on its activity, whether the activity is decrease or increase. But we know nicotine is not the drug. That is why we only use few methods which are used for the detection of structure, then finally synthesis. So now just we are doing only this one. So now here, this from this compound, this reaction, this suggests now nicotine isomethioiodide, and when it is treated with the potassium ferricyanide, K3 CN Fe, potassium ferricyanide. This is mild oxidizing agent. Potassium ferricyanide, that is alkaline in presence of base. We will get the compound same C10H13N2O. Here, instead of third, C10H13N2O. That is, as I told you, it is mild oxidizing agent. Plus, here will be methyl group. So, nicotine will become nicotone. It is converted nicotone, is it? Now, ketone. Nicotone. A ketone is obtained. When this ketone, why this reaction we are going to carry out? To confirm the structure of side chain. This reaction is used to confirm the structure of side chain, nicotone. And when again this further it is oxidized with the chromic acid, chromium trioxide, or chromium trioxide dissolved in the sulfuric acid, then a compound is obtained which will have a structure this. Here N-methyl, this becomes here carboxylic acid group. Because ketone, the carbonyl compound further oxidized, they are converted into carboxylic acid. So we will have this compound. That is here it is hygrenic acid. Hygrenic acid. Now hygrenic acid is the common name. If you give the systemic name, then you see it is here pyrrole, which is tetrahydropyrrole. Tetrahydropyrrole is also known as pyrrolidine. So it is pyrrolidine. Which pyrrolidine? N-methyl pyrrolidine. Then if you start numbering 1, 2, 3, that is we can call it N-methyl pyrrolidine 2-carboxylic acid. N-methyl pyrrolidine 2-carboxylic acid. Commonly it is known as hygrenic acid. So now again we are coming to this reaction. Nicotine when treated with the hydroiodic acid followed by methyl iodide. Methylation takes place. We'll get the nicotine isomethioiodide or isomethioiodide. This compound is isomethioiodide or isomethioiodide. When that compound is treated with the mild oxidizing agent in presence of base, then this was compound was converted into ketone, nicotone. When nicotone was further oxidized with this chromium trioxide is vigorous oxidizing agent. Then this compound was converted into this one, the hygrenic acid. So one of the product obtained, it was hygrenic acid. Hygrenic acid is also known as N-methyl pyrrolidine 2-carboxylic acid. This suggests this is the presence of side chain, because we know one of the portion from the earlier reaction, the pyridine is present. When first it was oxidized, if you remember the first reaction, then we got the nicotinic acid. Nicotinic acid was obtained by simple oxidation. So we know the one portion is that is pyridine. Another portion is this pyrrolidine, N-methyl pyrrolidine, which has the side chain at the 2 position. And in if you remember, the nicotinic acid. In nicotinic acid, pyridine contains the chain at the 3 position. Here there are the 2. We have these 2. Pyridine. Now from these 2 reactions we know pyridine is there, and pyridine contains the carboxylic acid at this position. 1, 2, 3 position. But here the carboxylic acid is present at the 2 position. Means now from at least from here we know that there are 2 portions of this compound alkaloid. Which one? One is pyridine having the side chain at the 3 position, and secondly the pyrrolidine which contains the side chain at this 2 position. Here 3 position, here 2 position. Now it means, and we know that this is saturated, and for further hydrogenation we know only 6 hydrogen atoms are added. It means that proves that only the pyridine is aromatic. Other portion is saturated. Now from this you say it is saturated, also not unsaturated, not aromatic compound. So at least we have 2 proofs that one portion is pyridine, another portion is pyrrolidine. Another proof is the attachment of these 2 rings. They are through this pyrrolidine at the 2 position and through the pyridine at the 3 position. Means the attachment of pyridine is attached with the pyrrolidine and methyl pyrrolidine at the 2 position. These are the facts that from this at least we know that the reaction, the compound contain, there are further reactions. Heterosynthesis. In heterosynthesis, if you carry out the reaction, there oxidation, sometimes mixture of sulfurous acid and sulfuric acid, then it at 103 to 140 degrees, it forms 3 acetyl pyridine, then oxalic acid, then methylamine. 3 acetyl pyridine, 3 acetyl pyridine, 3 acetyl pyridine. Here 3 acetyl pyridine plus oxalic acid. Oxalic acid normally we say 2 carbon plus methylamine. These 3 compounds are obtained, and these suggest that you see this now we call it heterosynthesis. If you combine these portions, it means pyridine. We have pyridine. It is attached with these. These are the fractions. If they combine together, how many carbons are? 1, 2, then 3. Fourth will be this one. 4 carbon containing structure in which there is nitrogen, then nitrogen containing methyl group. So now, and this is attached as the 3 position of the pyridine. And normally, again from this we know the pyrrolidone is also present over here. 1, 2, 3, 4. 1, 2, 3, 4. 4 carbons. 1, 2, 3, 4. 1 carbon this one. 2, 3, 4. So 1, 2, 3, 4. These are present in the side chain. And how many nitrogens are present? 1 nitrogen is already we say pyridine, and 1 nitrogen is in pyrrolidine. So again methyl group is there. So now we say the N-methyl group is present in the cyclic structure, and cyclic structure contains the 4 carbons, 1 nitrogen. Which nitrogen? N-methyl group. N-methyl is attached in it is a part of ring, and that part is 5-membered. 4 carbons are there, and 5th is nitrogen. This is one of the reaction. Another reaction is simple reaction again that support this one. That is here it is heated with barium hydroxide solution at 100 degrees centigrade. Then it forms nicotinic acid, malonic acid, and methylamine. Again I am repeating, if you heat it with barium hydroxide at 100 degrees centigrade, it forms nicotinic acid, malonic acid, and methylamine. Nicotinic acid, here same nicotinic acid, malonic acid, here, and methylamine. Also this suggests the side chain contain how many carbons? 1, 2, 3, 4. 1, 2, 3, 4. Here side chain contains this number of carbons. So again – side chain again prove this contains 4 carbons. 1, 2, 3, 4. 1 carbon this one. 2, 3, 4. 4 carbons. 1, 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 side chain contain the 4 carbons, fifth is the nitrogen, and it is a structure which contain also N-methyl group. Also this compound, from the reaction we carried out, that suggests there are how many what is the ring? There is pyrrolidine ring. And finally, we propose the structure. That is the pyridine is attached with the pyrrole ring. This was the proposed structure. This was the proposed structure. Here. Now from these reactions, there are 3 or 4 other reactions, but I think these are sufficient for here, because we know the structure of the side chain, that is pyrrolidine. We know the structure of one portion, that is pyridine, and we know the attachment points with the pyrrolidine at the 2 carbon, with the pyridine at the 3 carbon. So with the N-methyl group is lying over here. It contains the 4 member, means total number 5 member ring is there. Saturated ring, here aromatic ring, pyridine, and with the pyridine it is attached at the 3 position. So here, which prove that there are 2 main parts of this compound. One is pyridine, another is pyrrolidine. Pyridine, another is pyrrolidine. Which pyrrolidine? N-pyrrolidine. This actually, we want to prove this one. From other 2 reactions, just we prove that one portion is pyridine, which is aromatic, another the non-aromatic are saturated, and pyrrolidine. These are the 2 points. Third point is that there's the one, again I'm repeating, from the reactions, undergoing reactions, we know that there are 2 portions. One is pyridine, because in oxidation, simply oxidation, we got the nicotinic acid. There is one part is pyridine. From other reactions, we got the information that this contains N-pyrrolidine. Now, here we know that one is pyridine, another is N-methyl pyrrolidine. Now, second problem was the point of attachment. Here, from here, when we got the compound, finally we got the N-methyl pyrrolidine to carboxylic acid, and here nicotinic acid. So from nicotinic acid we say the attachment of, because nicotinic acid, the side chain was lying at the 3 position, so means the attachment of second ring is at the 3 position of the pyridine. And when we got hygrinic acid, then hygrinic acid, the side chain was lying at the 2 position. So at the 2 position of pyrrolidine and the 3 position of pyridine, these are the 2 points of attachment. When to attach these rings, now this is the proposed structure for the nicotine. Now this, as already I have told, the different methods are used to determine the structure. Final tool is just carry out the synthesis. If from the synthesis, if you prove the structure, then it means we can, if by different reactions, by different steps, if you can prepare the same drug, same compound, it means the structure of the compound is confirmed. So now we can use different reactions. Now, do you know this compound? What is the name of this compound? Now, one thing, here you see RCONH2. This is known as amide. This is known as amide. But when you say RCO, same compound NH, if it is form part of ring, NH connected to this is the lactam. This is a common. It is the lactam. Yes, lactam. It is amide. It is the lactam. So what is the lactam? Lactam is the cyclic amide. Just like the lactone is the cyclic ester. So lactam is the cyclic amide. This is the difference. Amide, lactam. Amide, open chain amide, it is closed chain amide. That is cyclic amide. Cyclic amides are known as the lactams. In this, what is happening? Here, you see, here carbonyl group is attached to the NH, and NH is forming a part of ring. This one, we can how we can define the lactam? These are the compounds in which carbonyl group is attached to the imino groups, NH imino group, and they are forming a part of ring. That is known as cyclic amide, or commonly known as lactam. Okay. Now similar compound. Now here is one carbonyl group. Here, if you say two carbonyl compounds, if they are attached to the amino group, and if they are forming a part of ring, then this compound will be known as Dalwani. Are you listening me? If the carbonyl group is attached to the amino group, it is a lactam or cyclic amide. But if the two carbonyl group, if they are attached to the amino group, and if they are forming a part of ring, that will be known as. Again, I'm repeating one common sense question. Here two carbonyl group. Now listen. Here two carbonyl group, if they are attached to the oxygen, if two carbonyl group, they are directly attached to the oxygen. These are known as anhydrides. Anhydride. Okay. But here two carbonyl group and anhydride of open chain acids. If they are forming a part of ring, then this is the anhydride of dicarboxylic acid. If the anhydride is of monocarboxylic acid, there will be no ring formation, open chain. Means two monocarboxylic acid, open chain monocarboxylic acid. If they combine together by the removal of water, we will get the anhydride. But if here two carbonyl group, if they are attached to the oxygen, and if they are forming a part of ring, it means it is anhydride of any dicarboxylic acid. Now here, when carbonyl group is attached to the amino group, we say amide, lactam. Sorry, simply amide, but when it is formed a part of ring, it was amide. But when two carbonyl groups are attached to the NH group, and they are forming a part of ring, this is known as imide. Imide. It is known as imide. Okay? Imide. The particular name depends upon the carbon. How many carbons are there? Now here you see this compound. 1, 2, 3, 4. 4 carbon containing carboxylic acid. Dicarboxylic acid is known as 4 carbon containing
succinic acid.
Succinic acid, yes. So this imide is succinimide. Imide of succinic acid or succinimide. Either you call imide of succinic acid or succinimide. Succinimide. Succinimide or we can also call succinimide, imide of the succinic acid. Succinic acid itself is also known as succinic acid. 1,4-butane, 1,4-dicarboxylic acid. 1, 2, 3, 4. Butane, 1,4-dicarboxylic. Means it is imide of 1,4-butane dioic acid. And when it is electrically reduced, or we can call it something electrolytic reduction. Electrolytic reduction is the selective reduction. That is only one. There are two carbonyl groups. So when you carry out the direct reduction, both will be reduced. When electrolytic reduction means selective reduction. Now we will have this compound. One carbonyl group will be reduced, and this will remain, one will remain as it is. Now here I have just succinimide. You must know all possible names. Succinimide is also known as imide of butane 1,4-dioic acid. Also this also known as, here you see it is pyrrole. When you write in this is pyrrole is an aromatic compound. But when you hydrogenate it, it becomes pyrrolidine. It will be known as pyrrolidine. Again, if you put here carbonyl group, pyrrolidinone. Again, which pyrrolidinone? 1, 2. 2 pyrrolidinone. If 2 carbonyl groups are there, 1, 2, 3, 4, 5. Pyrrolidine, 2,5-dione. Pyrrolidine, 2,5-dione. Or pyrrolidine-dione. So now, here the second name of succinimide. Succinimide or imide of succinic acid or imide of butane 1,4-dioic acid, or we can also call it pyrrolidine 2,5-dione. And again, when it is electrolytically reduced, then we will get this pyrrolidine 2-one. Pyrrolidine pyrrolidine 2-on or 2-pyrrolidinone or pyrrolidine 2-on. And with this,
gamma butyrolactam
yes. You see alpha from here. We started from here. Alpha, beta, gamma. That will be gamma, beta. How many carbons are there? 1, 2, 3, 4. Beta, gamma, butyrolactam. Gamma, butyrolactam. Beta, gamma, butyrolactam, or it is also known as pyrrolidine 2-on or 2-pyrrolidinone, or also it is known as pyrrolidine. This is also known as the cyclic amide of how many carbons there? Cyclic amide of 1, 2, 3, 4 carboxylic acid. 4, that is butyric acid. Cyclic amide butyric acid. So these are the different names. And when this compound is treated with the methylation. For methylation, normally we use either methyl iodide or dimethyl sulfate. If anybody asks from you what is the use of methyl iodide or dimethyl sulfate, we say their function is methylation. Mostly O-methylation or N-methylation is carried out with the either dimethyl sulfate or methyl. Most commonly with the dimethyl sulfate. So now when this compound is treated with N-methylation, this is N-methylation. N-methylation.
2-on जीता करी पार.
हाँ हाइले नहीं हले बन कहीं.
इनकी methylation मना यही पे हले.
हाँ जी हले बन. बस next step में वापस कौन आते? इनकी electrolytic reduction कहीं तपान की compound मिलो. Now this compound is treated with the dimethyl sulfate. So what happens? Remaining compound will be 7. Only methylation will take place. So now we'll get the methyl N-methyl same. Other name will be the same. N-methyl 2-pyrrolidinone or 2-methyl-pyrrolidine 2-on. Now, when this compound, now let me write here, same compound here, same compound. I'm writing over here, N-methyl. When this is treated with the ethyl nicotinate, when it is treated with the ethyl nicotinic acid is, this is the nicotinic acid. Nicotinic acid is the acid, and its ethyl ester will be ethyl nicotinate. Here, ethyl nicotinate is treated with this compound, N-methyl 2-pyrrolidinone. When they mix together, when they react together, then what happens? Ethyl nicotinate and N-methyl 2-pyrrolidinone. When they react together in presence of ethyl sodium ethoxide. Sodium ethoxide. If you remember this reaction, what is the name of this reaction? Dykman reaction. If you remember the name of this reaction, this Dykman reaction, just like the Claisen reaction, Claisen condensation. So what happens? Here you see ketonic group. When there is a ketonic group, it is directly attached to this carbon. This carbon contains how many hydrogens? 2 hydrogens. So this ketonic group is electron attracting group. When electron attracting group is there, what happens? This will make these hydrogens. Hydrogens which are attached, acidic hydrogens. These hydrogens becomes active hydrogens. So if they are treated with the sodium ethoxide, what happens? One of the hydrogen, just I am writing in one step. When this compound is treated with the sodium ethoxide will pick up one hydrogen, and this will convert this compound into carbonyl. A negative charge will come over here. Once negative charge comes over here, then what happens? This will attack on this carbon. This carbon is nucleophilic. Here oxygen nucleophilic, carbon electrophilic. So through this oxygen, this will attack on this carbon. Now once this attack on this carbon, then what happens? इनके बेटा इनके साफ करेंगे ना बता जगह को नहीं दी इनके साफ क्या दो
Yes, sir.
ठीक है. Now what happens? How we got this carbonyl? By treating with this sodium ethoxide. We got the the carbonyl of N-methyl 2-pyrrolidinone. So now, once it attacks on this one, what happens? We will have this compound pyridine here. Polarization will take place. O negative here, same OC2H3 group, that is ethoxy group. The remaining same attachment take place at this position. Let me write. Here. C3. And then these electrons will come back here and this will be given out. So now we will have here 1, 2%, 1, 2, 3%. Here, you are someone we will have this compound. O this compound will be formed.
पैरालेडिन जो ऑक्सो ग्रुप
ऑक्सो ग्रुप
टू पोजीशन वाला
जी सर यही
हाँ वो लगा
जी जी सर
वो प्योर है वो
जी सर सही है
वो प्योर है ठीक है now this is again heated with the hydrochloric acid at 130 degrees centigrade this compound then ring cleavage will take place. Ring cleavage take place at this point. At this point. So what happens here? Remaining question here as it is. Methyl. So here and CH3 and then here carboxylic acid. This compound is formed when treated with the hydrochloric acid at 300 degrees centigrade, 130 degrees centigrade. Okay, yeah. And this again we can write actually what happens if you treat simply with the hydrochloric acid. The reaction breaking will take place if you warm it. But if you heat it at high temperature at 130 degrees centigrade, what happens? First, this compound is converted to carboxylic acid and then decarboxylation will take place. What is the decarboxylation? Removal of carboxylic acid in the form of carbon dioxide. Remain as it is here. Only here this group will be removed in the form of carbon dioxide. Here. Here. O. Then here. Here. And so we'll have this compound. At this point, carbon is there also. So now we will have this compound. And here carbonyl group is also there. Carbonyl group 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 4 carbon. 1, 2, 4 carbons. 4 carbons. And one is N-methyl group. Now, what will be the name of these compounds? Because we must at least the names which are simple, we must know the names of the compound. Name of this compound first. It was N-methyl 2-pyrrolidone. Just leave it. There is 1, 2. 2-methyl N-methyl 2-pyrrolidone. At the 3 position, this group is no is there. This group is no iso. This group is nicotinyl. You know this group CH3. CH3. It is acetic acid. If you remove this OH, this becomes acetyl. Acetic acid, acetyl. Acetic acid. Two nicotininyl, yes.
4 amino.
4
4 amino.
4 no, not 4 amino. अन्य हेटेरो गलती को करें.
4
4 methyl amino.
Yes, methyl amino.
4 methyl amino. ठीक है. 2 nicotininyl, 4 methyl amino.
Methyl amino. Butanoic acid.
Butanoic acid. Yes, butanoic acid. R या अल्फा बीटा डिनर अल्फा बीटा गामा अल्फा निकोटिनाइल गामा मिथाइल अमाइनो ब्यूटारिक एसिड समझो नाम से 2 निकोटिनाइल 4 मिथाइल अमाइनो ब्यूटारिक एसिड आर अल्फा निकोटिनाइल गामा methyl amino butyric acid. When it is treated with hydrochloric acid 100 degree centigrade, then what happens? It undergo decarboxylation, and now we will have this compound. Again, this compound, you see, this compound is known as how many carbons? 1, 2, 3, 4. Now, without this, it is 4 carbon. 1, 2. How many carbons are 4? So it is butanoyl. Butanoyl. Butanoyl is also known as butyryl. So now here position 1, 2, 3. R is 2 is alpha, it is beta. Pyridine. In the pyridine we have this group. There 3. Okay. 3. Here 4 methyl amino butanoyl. First is beta. 2, 3. 3. Then bracket. 3 bracket and means 3 position in the pyridine. 3 now here again 4 methyl amino then bracket over. Actually we have to give the 2 bracket here, larger bracket then here smaller bracket here 3 position of pyridine 4 methyl amino then butanoyl pyridine. It's IUPAC name. If you give the common name, then just change the position. Here will be beta position of pyridine, same bracket. Now 4. Now with respect to this 1, 2, 3. This will be alpha, beta, gamma. Beta, then here dash, gamma, remaining same methyl amino. Butyryl, here butyryl, gamma, methyl, amino, here butyryl, pyridine. Okay? And now, when this compound is treated with the hydroiodic acid at 100 degrees centigrade. Hydroiodic acid at 100 degrees centigrade. Hydroiodic acid at 100 degrees centigrade. Then what happens now? Here this will undergo. We can write now in book. You will find it, way of writing is just different to make it more easy for the cyclization purpose. We can write this as here in this way. It is same. How many carbons are here? Ketonic group.
सर पिने तो हम कार्बोनाइल ग्रुप के OH में कन्वर्ट करे उनका बाद में हाइड्रोआयोडाइड से रिएक्शन करेंगे ना
Hello, you say it?
जिंक
That is also correct. We can, if you treat with the जगह करना डिकार्बोनेशन को करना जगह डायरेक्ट इनसे डायरेक्ट कर दो स्टेप किताब में तो ये लिखल पर नहीं पढ़ करू चाहे पढ़ेंगे द रिडक्शन दैट इज वुल्फ क्रिस्टल रिडक्शन आर केमिकल रिडक्शन
इथेनॉल जी करे बैठो ना तो OH ग्रुप में कन्वर्ट थी ना
OH में करना OH के करण पर रिप्लेस दैट इज सब्स्टिट्यूशन रिएक्शन बोथ वेज आर देयर सो फर्स्ट यू treat it with and the reducing agent, then what happens? Reduction will take place, CO group will be reduced, then iodination with the hydroiodic acid. So the iodine group will be introduced. Let me write it so simple. So now we will have here this way. Althagi, CO will come over here. First you reduce it, CO group, okay. Then iodination. When you carry out iodination, this iodine group will be here. This will contain hydrogen. ठीक है ना? बाकी remains same. Just way of writing is different. Otherwise, same compound here. If you reduce it, CH2 group. That is reduced first. Then hydroxy group will be there. If you treat it with hydroiodic acid, then nucleophilic substitution, the alcohol will be converted into iodo compound. And once it is converted into this compound, then what happens? Cyclization will take place if you treat it with the potassium hydroxide. Potassium hydroxide means the elimination reaction. So this will be removed. That is hydroiodic acid, hydrogen iodide. And now we will get here this compound. That is and this compound is known as nicotine plus minus nicotine. It will be racemic mixture of nicotine. And racemic mixture, that is the basics because both nitrogen are
organic acid sign के resolve करे थे ना
organic, yes, organic. Most commonly we use we can use any organic. Most commonly it is tartaric acid. So if you use plus tartaric acid, we will get the plus nicotine tartarate plus nicotine plus tartarate. Another will be minus nicotine minus plus tartarate. So two type of crystal will be obtained. Then we fractional crystallization. We can separate the one of the form because the naturally occurring nicotine is minus nicotine. That is the liver O2 So here now resolve through tartaric acid. We will get here minus nicotine. So from this, now this it confirmed that whatever the structure we have proposed, that structure is confirmed. ठीक है बाबा?